So now we'll take the information that we learned on the previous page and apply it to this problem where we'll find the area of the region bounded by the graph y is equal to 1 over x squared and y is equal to negative x. Looking on the interval from x is equal to 1 and x is equal to 2. To calculate our area between the two curves, we're going to find the integral from 1 to 2 of our top curve, which is the 1 over x squared, minus the bottom curve, which is negative x. So we'll set up our integral from 1 to 2 of 1 over x squared minus negative x. Simplifying the problem to read antiderivative from 1 to 2 of x to the negative 2 plus x dx. We'll antiderive to get negative x to the negative 1 plus 1 half x squared from 1 to 2. Using the first fundamental theorem of calculus, substituting in 2 for x, subtract substituting in 1 for x. Then simplifying to solve to get our solution. In our next example, we're going to find the area of the region bounded by the graphs f of x is equal to the square root of the quantity 3x plus 1 and g of x is equal to x plus 1. In the area between the two curves, we can see that we're going to do the integral of f of x, which is the function on top, minus g of x, which is the function on the bottom. But we don't have an interval with which to work with. We can see that the two graphs intersect at 0, and we need to determine what other x value the two graphs intersect at. So we'll go ahead and take g of x set it equal to f of x in order to get that intersection point. So we'll take x plus 1 is equal to the square root of 3x plus 1, subtracting x from both sides, then squaring both sides, bringing over the 3x, factoring out an x. Our two intersection points are x equals 0 and x is equal to 3. So when we calculate our integral, we'll be going from 0 to 3 of f of x minus g of x. The integral from 0 to 3 of the square root of 3x plus 1 minus the quantity x plus 1 dx. Simplifying the problem by distributing the negative. Then combining like terms. Rewriting the square root of 3 over x is the square root of 3 times the square root of x. And again, rewriting the square root of x as x to the 1/2. Now we're ready to antiderive. So the antiderivative will be the square root of 3, 2/3 x to the 3/2, minus 1/2 x squared from 0 to 3. Following the first fundamental theorem of calculus, substituting in 3, then subtract substituting in 0 to get our solution. We're going to find the area of one of the regions that's bounded by f of x is equal to sine x and g of x is equal to cosine x. We need to calculate the area of the top function minus the bottom function. The top function is g of x, and the bottom function is f of x. We'll also need to calculate the intersection between f of x and g of x. So we'll take cosine of x, set it equal to sine x. Using our unit circle, we'll get the intersection at the two x values. We'll use this interval to antiderive and calculate our area. The final example is going to find the area of the region bounded by f of y is equal to 2y minus y squared and g of y is equal to negative y. 2y minus y squared is a sideways parabola intersecting at 0 and 2 on the y-axis. shading in the area. You might want to think of that flipping the picture to see what the top and the bottom of the function is. Set our two equations equal to each other to find the intersections. Subtracting over 2y to get y squared minus 3y, factoring out y. The intersection is going to be at y is equal to 0 and y is equal to 3. So the area between our regions is going to be the integral from 0 to 3. The top function will be 2 minus y squared, and the bottom function will be negative y. Notice that our interval uses y values. So we'll antiderive from 0 to 3, 2y minus y squared minus the negative y dy. Simplifying the problem, we'll have 0 to 3 is the interval 2y minus y squared plus y dy, which again simplifies to negative y squared plus 3y. Anti-deriving to get negative 1/3 y cubed plus 3 times the quantity 1/2 y squared from 0 to 3. Following the first fundamental theorem of calculus, we're placing in our value for 3, and then simplifying to get our area.